Welcome back to the deep dive. If you're feeling maybe a little overwhelmed by the AI news cycle lately, well, you're definitely not alone.
Yeah, it's been relentless, hasn't it?
Totally. We've seen this just tidal wave of major releases. Google pushing out Gemini updates, Anthropic dropping Claude 4 Sonnet, OpenAI constantly tweaking things. It's a lot.
It really is. Hard to keep track.
But, amidst all that noise, there was one key shift, a methodological one, that I think, frankly, flew completely under the radar for most developers.
Oh, which one are you thinking of?
The BMad Agent V3. It's
Yeah.
officially here. And I think it's really changing how serious teams are starting to approach AI-assisted development.
BMad V3. Yes, I agree. That one's significant. Less flashy than a model release, maybe, but potentially more impactful day to day.
Exactly. So our mission today is to pull this new framework out of the shadows and really do a deep dive into the whole methodology. BMad stands for Balanced Modular Agent Development. And it's not just, a collection of prompts. It's being pitched as a formalized framework. The claim is it's the shortcut to building robust full-stack applications.
How? By orchestrating multiple AI agents, specialized ones.
Precisely. Multiple agents working together. The idea is you simplify this immense architectural complexity, and this is the key part. You ensure your big multi-file project actually stays on the rails.
Stays on the rails.
From that initial idea all the way to the final commit. No more going off into the weeds halfway through.
And that concept, staying on the rails, that's exactly why V3 is being seen as, well, a revolutionary update by the folks developing it.
Right.
Because previous attempts at AI-driven development, they often just descended into chaos, didn't they?
Oh, absolutely. Total mess sometimes.
But BMad V3, it seems to finally marry simplified power. I mean, it's actually easier to set up now with full customization.
Okay, that's a good combo.
So for anyone who's been waiting, maybe hesitant, wanting a structured, a non-chaotic way to bring these powerful LLMs into a serious development pipeline, maybe even enterprise level.
Yeah.
This moment, V3, this is probably the time to jump in and adopt this structured approach. It directly tackles the biggest headaches we've seen over the last, 18 months of using generative AI for code.
Okay, so let's start there then. Let's define the problem BMad V3 is trying to solve. The source material we looked at calls the common approach vibe coding, which I love, by the way.
Yeah, vibe coding. It's evocative.
It really is. We've all done it, right?
Yeah.
You fire up a powerful agent, GPT-4, Claude, whatever, and you say, hey, build me a Next.js app with a Supabase backend and, 3 APIs.
And then you just sort of vibe check the output, see what happens.
Exactly. You just vibe check it as it goes.
Yeah.
But if you've tried this on anything more complex than, say, a single file or a basic landing page, well, you know the flaws, big flaws.
Oh, yeah. It breaks down fast.
Our source material breaks down like 4 major points of failure that just doom complex projects built purely on vibes.
Okay, what's the first one?
The first, and maybe the most frustrating, is what the source calls the agent going right off the rails.
Right. Seen that happen.
The more complex the project, more files, more interdependencies, the harder it gets for that single big agent to keep track of everything, to maintain context across the whole file system.
The context window just gets swamped.
Totally. So you might be halfway through, maybe you've coded up 3 critical features, 3 epics, and then the agent just starts making really poor decisions, contextually poor.
It loses the plot, forgets earlier decisions or constraints.
Yeah, it loses the plot because the context is just overwhelmed.
Yeah.
And that leads to what the sources politely call dumb things.
Dumb things, yes. Code that makes no sense, breaks existing stuff, you name it.
And that loss of context, it feeds directly into the second major problem. Massive wasted resources.
The cost.
If you skip the planning, skip the optimization up front, you are literally burning money.
Yeah.
Burning API credits.
Because the agents don't know the best path forward if they haven't been forced to think ahead, right?
Yeah.
They just react locally.
Exactly. No foresight.
And it's actually worse than just waste. It locks developers into this constant reactive mode, fixing the AI's mistakes instead of building features.
Do the sources quantify that waste?
They did, actually. They estimated that agents running without a BMad-like structure, so no defined artifacts, no clear steps, they averaged about a 45% overspend on token credits.
45%, that's huge.
It's massive, and it's all down to redos, unnecessary refactoring because the AI went off track using non-optimized code paths. It adds up incredibly fast.
So it's a huge financial drain, not just a coding annoyance.
Precisely. The BMad method tries to make that initial plan act like a sort of financial forecast for your token use, minimize those expensive reactive loops later.
Okay, point 3 against vibe coding.
Sheer lack of memory and organization.
The random file placement issue.
Exactly. Vibe coding means agents just sprinkle files wherever they feel like it, random, illogical places.
And they forget where they put them.
Right. Or they forget the architectural decisions they made just a few steps ago. There's no persistent memory, no enforced structure.
So you get instant technical debt, unmanageable debt, because nothing forces organization.
And if you hit that tech debt wall, you crash right into the fourth pain point, change recovery.
Well, this one hurts.
It really does. Imagine you're halfway through your MVP, you've got most of your high-value stories done, and then disaster. You realize you forgot a major security feature.
Or worse, maybe the market shifts and you need a big technology pivot. Swap out the database or something.
Exactly. Historically, recovering from that, going back manually checking the, 30, 40 files the AI might have touched, it's been a nightmare, a real pain.
So the whole point of BMad is that it actually supports change recovery.
Yes, because it insists on planning first. That's the core belief, really.
Yeah. Planning. Distilled down to 3 steps.
Right.
Help the AI brainstorm the idea, then define the structure, and then put that structure into motion.
Right. Brainstorm, define, execute. That sequence ensures the developer agents have a crystal clear, step-by-step path. They know what to do next, which maximizes their output quality and keeps them on track.
Okay, so that's the evolution, isn't it?
Right.
We went from chaos, from vibe coding.
Then we had tools like, say, Cursor with some internal rules. An improvement, but still felt kind of fragile, maybe not fully optimized. BMad V1 introduced templates, but the agents were hard-coded to tasks. Customizing was hard, and running them got expensive.
Which brings us to V2, the real stepping stone for V3.
Yeah, V2 was critical. It did 2 key things. First, web utilization,
Meaning?
moving a lot of that planning work out of the IDE, out of your code editor,
Why?
to save time, save money, and leverage the deep web research capabilities of the big models like Gemini or Claude. Do the thinking and research where it's cheapest and most powerful.
Okay, makes sense. And the second V2 innovation?
Templates and checklists, but defined in separate files.
Modularizing the definitions.
Exactly. So agents could work section by section on an artifact like a PRD and collaborate with the user. This was great for producing clean, well-structured documents, product requirements, docs, architecture specs, and so on.
V2 still had a problem. It was complex to set up.
It was. And this is a critical technical point that V3 specifically addresses. The sources highlighted significant compatibility challenges.
Between what?
Between different LLM environments, specifically getting the same agent set up to work smoothly in, say, Google's Gemini platform versus custom GPTs in OpenAI.
What was the friction?
Mostly prompt limitations and file sizes. In V2, your main agent definition file, the prompt, had to contain everything, the rules, the personas, the checklists.
And that file gets big fast.
Really fast. If that core instruction set ballooned past, say, 500 kilobytes, which happens easily when you define a full agile team and all its constraints, some popular platforms would just flat out reject it.
Okay, so that limited where and how you could use V2 effectively. Big adoption barrier.
Precisely. And that is V3's elegant solution. It's quite clever, technically.
What do they do?
BMad V3 optimized this by realizing something crucial. The platform, like Gemini or ChatGPT, can handle the agent core, a small, streamlined definition, really well.
Okay.
But those big, chunky details, the templates, the checklists, your specific coding standards, those can be uploaded as separate knowledge files.
Decoupling the core logic from the detailed knowledge.
Exactly. The results. The agent definitions themselves got way smaller, but the overall power and flexibility increased massively.
And that makes them portable.
Perfectly portable. This streamlined structure ensures the agents work consistently across different environments. It dramatically simplifies the setup and lowers the barrier to adoption. That's why V3 feels like the game changer. It made this complex, structured approach finally accessible.
Okay, so if V2 cracked the code on modular artifacts with templates, there was still a missing piece, wasn't there?
Yeah, you had the sheet music, but you needed the conductor.
Nice analogy. That structure is only useful if there's a superstar orchestrator in charge. Which brings us then to the BMad Agent V3 itself, the core agent.
The ultimate AI orchestration partner, as they call it.
Right. So this single BMad agent, it acts the method coach, it organizes the whole AI Agile team. But the genius part seems to be its adaptability.
It's like a chameleon.
Explain that.
It dynamically adapts. It becomes the specific agile agent you need at that moment. It draws on the right expertise. Maybe it needs to be the product manager for a bit, then switch to Scrum Master,
And
product owner.
so it's one agent wearing many hats, all driven by this core BMad philosophy.
Precisely. And this dynamic coordination, that's the real V3 customization breakthrough. Before, agents were kind of monolithic, hard-coded.
Right.
Now, the functionality is split into 3 fully customizable layers. Layer 1, roles or personas.
Okay, what's a role?
It defines the agile identity, the persona, and importantly, its core, always active principles.
Give me an example.
Okay, so the product manager persona, it's explicitly tuned. Its core principle is to always champion the end user and focus on market viability.
And the architect.
The architect persona is tuned differently. Highly analytical, laser-focused on performance trade-offs, scalability, security. These principles are ingrained. They act as guardrails for how that persona behaves and makes decisions.
Okay, so roles define the who and their core beliefs. What's the second layer?
Tasks. This is a functional split. BMad V3 separates out capabilities. Things like run checklist, perform course correction, create a PRD, generate via 0 prompts.
These aren't tied to one role.
Exactly. They're split out into modular definitions. Any agent persona can pull in a specific task definition and execute it if you allow it to.
Oh, that's powerful. So you can control capabilities granularly.
Totally. You define exactly which tasks an agent can do, what templates it can access, which checklists it's allowed to run. It allows for massive specialization without building entirely new agents from scratch every time.
Mix and match capabilities with personas.
Right. And that modular task-based approach leads directly to the third layer, personalization.
Okay.
The core BMad agent can now be fully customized. You can incorporate whatever specific agents, tasks, checklists, and personas you want or need.
So I could build like a specialized DevOps architect.
Absolutely. One that focuses only on, say, AWS CDK or Terraform tasks. Or you could specialize your developer agents for a niche language, maybe embedded C++ or high-performance Python for data science. The system adapts to your specific tech stack.
That's incredibly flexible. Now, you mentioned something earlier about workflow efficiency and how this ties into the underlying LLM tech.
Oh, yes. This is where it gets really interesting, especially with the newer models.
What's the connection?
The source material highlights that using powerful platforms with huge context windows, they specifically call out Gemini 1.5 Pro.
Which has what, 1 million tokens? Or even 2 million now?
Exactly. Massive context. This allows most of these specialized BMad agents, the PM, the architect, the designer, to actually run within the same chat thread.
Wait, all in one chat, not separate sessions for each agent.
Mostly, yes, for the Webflow especially. And that is the aha moment for context windows that just fundamentally changes the workflow speed.
How so? Explain that.
Okay, think about the old way. Agent A, the brainstormer, creates a document, right?
Right.
Agent B, the product manager, needs to use it. What do? You copy the text, maybe save it as a file, then you paste it or upload it into Agent B's chat.
And Agent B has to read it, understand it.
Exactly. It has to reread and re-internalize the whole thing. That takes time, costs tokens, and you can even lose subtle context in the transfer.
Great, the serialization, deserialization problem.
Precisely. Turning the artifact into text, sending it, having the new agent parse it all over again. By keeping these specialized agents in one single massive context thread, you leverage the LLM's huge memory pool.
So they can just pass things around internally.
Virtually, yes. They pass brainstorming docs, PRD briefs, architecture notes, design specs, all around in memory within that shared context window.
No exporting, no re-importing.
None of that constant, expensive, latency-inducing transfer step. It means you can have really long, really complex conversations, like defining an entire application from idea to detailed spec before the agent even starts to lose context or hallucinate.
That must speed up the initial definition phase dramatically.
Massively. The whole Webflow portion just becomes much faster and more coherent.
Okay, so let's walk through that Webflow. You've got your BMad agent set up, and you said the setup is easier now.
Yeah, much easier. Clone a repo, copy the main agent prompt, upload maybe 6 or 7 knowledge files like templates and checklists. That's pretty much it.
All right, so you're set up. The methodology then takes you through this clear idea to implementation path using those specialized agent personas. It starts with the Webflow, which is all about definition and design, right? No coding yet?
Correct. All happening ideally within that large context window environment.
Okay, but let me pause here. Let me play devil's advocate for a second.
Go for it.
All this upfront planning, the PRD, the source tree definition, the master checklist, Doesn't that just slow things down? Isn't the whole point of using AI to get to code faster? Are we just recreating old school waterfall or heavyweight agile processes, but with AI doing the typing?
That's a very fair question. It really gets to the heart of the tension in AI development, doesn't it? Speed versus structure.
Yeah.
The answer, according to the BMad philosophy, is no. It's not just old processes with a new coat of paint. And here's why. The creation of those planning documents, the PRD, the architecture, is also managed and accelerated by specialized AI agents.
Ah, so you're not spending a week manually writing a PRD yourself.
Exactly. The product manager agent works with you to draft and refine that PRD, maybe in an hour or two, leveraging the LLM's ability to structure information and research competitors. The architect agent does the same for the technical blueprint.
I see. So you use the AI speed to create the guardrails faster.
Precisely. You leverage AI speed to build the structure, and that structure then allows the coding agents downstream to run at maximum velocity without making those costly mistakes we talked about, that 45% token overspend. It's structure for speed, not instead of speed.
Okay, I get it. The AI helps build the plan so the plan isn't the bottleneck. All right, let's trace that process, friend. Step 1 in the web flow.
Brainstorming and conceptualization. This is handled by the Business Analyst Coach persona.
Okay, what does the business analyst do?
Let's say you just have a seed of an idea, a hunch, a feeling there's a gap in the market. This agent helps you flesh that out.
Oh.
It helps you form a conceptual product brief. It does deep research on the web, looking for competitors, seeing what similar products do well or poorly. And crucially, it helps you identify your unique selling points, your differentiator.
So it forces market validation before you even think about code.
Exactly. Is this idea viable? Is it interesting? Does it solve a real problem? Nail that down first.
Makes sense. So once you have that validated concept brief,
It gets virtually handed off in context to the next agent, the product definition specialist, the product manager persona,
and the PM's job.
to elicit requirements from you and define a clear product requirements document, the PRD.
And this isn't just a simple memo.
No, absolutely not. The PRD generated by the BMad PM agent is quite detailed. It includes high-level epics, user stories, and importantly, they're arranged in the correct execution order.
Why is the order so important at this stage?
Because that sequential plan maximizes the efficiency of the developer agents later. They know the logical build order, which minimizes rework and dependency issues.
Okay, concept validated, PRD defined. What's next?
We move beyond the what and into the how it looks and feels. This is the design vision phase, handled by the specialized UI/UX design architect persona.
And this agent's job is to prevent, what was the phrase?
Generic tailwind vibe coded crap.
Right, that stuff is everywhere. So how does the design architect prevent it? It has 3 functions.
3 critical functions, yeah. First, it creates high-quality, single-shot prompts for those AI front-end generator tools, like V0 by Vercel or Lovable.
Single shot, meaning one prompt builds the whole UI.
Pretty much. Because the agent has the full context, the PRD, the MVP scope, the basic architecture, it can generate a really detailed prompt that tells V0 exactly what to build. All the pages, the components, the basic layout. It dramatically cuts down front-end dev time.
Wow, okay. Function 2.
It defines the full UX/UI specification. This is where the look and feel comes in. Themes, colors, typography, overall visual vision. It ensures the output isn't just functional, but also stylistically unique and coherent. It codifies the aesthetic. It can take inspiration from images you upload.
Oh, interesting.
Yeah, you could upload, say, a picture of an 80s movie poster or a screenshot of a website whose theme you like, and the design architect can analyze it and distill those visual ideas into the UX/UI spec. It helps translate your visual taste into something buildable.
Okay, vision set. We know what it does. We know what it looks like. Now the technical blueprint.
Exactly. Phase 4, technical blueprint, handled by the application architect persona.
What does it take as input?
It takes the PRD requirements, passed virtually in memory, and gets down to the nitty-gritty. It creates the source tree structure, defines where files will go, makes and justifies all the key architecture decisions.
Like database choice, authentication, API patterns.
All of that. And what's really fascinating here is the customization V3 allows. If you're an experienced developer, you can feed the architect a document with your preferred coding standards, your favorite design patterns, maybe you insist on the repository pattern everywhere, your specific tech choices.
And the agent just accepts that.
It not only accepts it, it's trained to critically assess it. It might say, okay, you want to use technology X, but based on the PRD's scalability requirement Y, have you considered the trade-offs with technology Z? It engages you in a discussion.
And what if you're a beginner?
Then it's arguably even more valuable. It doesn't just pick a database, say PostgreSQL. It explains why. It might show you the trade-offs compared to MongoDB or CockroachDB based on the specific needs outlined in the PRD.
So it teaches you architecture as it goes.
Exactly. It forces the LLM to justify its choices, present alternatives, and help you understand the why behind the technical decisions. It's collaborative learning.
Okay, this Webflow produces a lot of detailed artifacts.
Mm-hmm.
PRD, design spec, architecture doc. Is there a final check?
Yes, absolutely critical final step. The gatekeeper, the product owner persona, or PO.
What's the PO's main job here?
In the Webflow, its primary function is running what the source calls a masterful checklist against everything produced so far, the architecture, the PRD, the design output.
A final sanity check.
More than sanity. It's a coherence and completeness check. It enforces a critical validation layer on what the LLMs created.
What kind of things does it check?
Does the architecture actually support all the features in the PRD? Did the architect account for that asynchronous API call needed for feature X? Is the database schema detailed enough for the relationships required by story Y? Are the design elements consistent with the technical constraints?
So it looks for gaps in logic, things that would block the developers later.
Precisely. It forces a rigorous conceptual review across all the documents, ensuring they're cohesive, updated, and ready. Once the PO signs off on that checklist, you have your polished set of artifacts ready to take into the IDE for implementation, #tag4, implementation and course correction, the IDE flow.
Okay, so Webflow complete. We have these high-level, cohesive, validated artifacts, PRD, architecture, design spec. Now we transition into the IDE, the integrated development environment. Code time.
Almost. First, a crucial step happens in the IDE, run usually by the Scrum Master or maybe the product owner persona. It's called the document sharding task.
Sharding, like breaking things up.
Exactly. This is what gives the downstream developer agents their detailed intelligence. The sharding task takes the high-level PRD and architecture docs.
The ones created in the Webflow.
Right, and it breaks them down into much more granular, highly detailed, lower-level stories, tasks, and even subtasks. It's the translation layer from conceptual design to concrete coding instructions.
What kind of artifacts does this sharding produce?
It generates several crucial, very detailed sharded artifacts that act as the guardrails for the actual coding. Things like separate epic files, a detailed API reference document listing all endpoints and their specs, definitions for component views.
And you mentioned two were most important.
Yes. One is the explicit project structure file, usually a JSON file detailing exactly where every single file should go in the source tree, no ambiguity.
Okay. Prevents random file placement. What's the other critical one?
The data models document. Absolutely vital. If the AI gets the database schema or the data structures wrong, the whole project can derail, so this artifact spells it out precisely.
And this level of detail from sharding, that's what keeps the developer agents on the rail.
That's the idea. The detail is so high, the instructions so explicit that it guarantees the developer agents, the workhorses actually writing the code, know exactly what to do, where to put things, what protocols to follow.
And you don't need lots of extra rules inside the IDE itself.
Right. Critically, you don't need to create tons of separate, fragile rules or constraints within the IDE agent prompts. The agents get everything they need just by reading those sharded artifact documents for the specific story they're working on.
This detail includes specific versions too, right? That was a key V3 point.
Crucial point, yes. Explicit versioning. The agents are trained to be specific. The architecture won't just say use Axios for HTTP requests. It will specify use Axios version 1.6.x.
Why is that so important? Seems like a small detail.
It prevents absolute chaos. Think about the danger of generic instructions. Let's say the architecture just says use Axios or fetch. The developer agent starts coding a story, uses Axios, makes a small mistake, maybe a typo. The unit test fails. Now, instead of debugging the Axios code like it should, if it's not tied down, the agent might just decide, oh, this Axios thing isn't working, I'll just install fetch instead. And suddenly, you have two different HTTP libraries in your project. Maybe conflicting versions, it leads to bloat, confusion, those dumb mistakes.
Architectural anarchy, basically.
Exactly. So the explicit architecture and versioning in V3 prevent that anarchy from the start. The agent's choices are constrained by the plan.
Okay, that makes sense. But plans change, right? What if you do need to make a major shift halfway through coding? The database example you gave earlier.
Right, the inevitable happens. Projects pivot. That's where V3 introduces a major new feature. the course correction agent.
Dedicated to handling big changes.
Yes. Let's say you're halfway through the MVP build, stories are getting done, code is being written, and the business says, stop, we're throwing out PostgreSQL, we need to go serverless with DynamoDB.
Big change.
Okay, panic stations. Not necessarily with V3. You invoke the course correction agent. It works with you, using its deep context of all the work done so far, all the artifacts.
And figures out the best way to pivot.
Exactly. It helps determine the strategy. Do we need to discard some already completed stories? Can we just update the data model artifacts and maybe tweak the API specs pivot in the sand, so to speak?
And then it updates everything.
It quickly updates all the necessary artifacts, the project structure file, the data models, the API refs, and critically, all the future remaining user stories that haven't been started yet. It ripples the change through the plan.
So it minimizes the pain and gets the project back on track faster after a pivot.
That's the goal. Dramatically reduce the fear factor of committing to an architecture early, because you have a structured way to change it later if needed.
Okay, one last feature you mentioned for V3 was about the agent critiquing itself.
Yes. The advanced reflective elicitation and brainstorming actions. That's a mouthful.
What does it do?
Basically, when you ask the agent to review critical documents, like the PRD or the architecture it helped create, it doesn't just say, looks good. It offers you, 8 different options for how it can self-reflect and suggest improvements.
8 options for self-critique.
Yeah, it's pretty sophisticated. This is where the AI goes beyond just executing instructions and starts doing genuine critical analysis.
Okay, give me some examples. What are some key options?
All right, one key option is user goal alignment.
Checking if it's still on mission.
Exactly. It forces the agent to step back from the technical weeds and ask, is what we're building still aligned with the original project goals defined way back by the business analyst?
Can you give a hypothetical example of what it might say?
Sure. It might prompt something like, okay, reviewing the current back-end API decisions, I see we've chosen GraphQL for its query efficiency. However, does this still align with the original user goal of keeping front-end complexity absolutely minimal for faster iteration? Or should we perhaps revisit a simply REST implementation for this specific phase?
Wow. It's checking its own technical choices against the original business rationale.
Right. Second key option, generating and evaluating alternative design solutions.
Proposing different ways.
Yes. It forces the agent to present maybe 2 or 3 viable alternatives to its current design choice, say a different database migration strategy or a different authentication flow. Then it has to defend why its initial choice was superior. Or critically, it might analyze the alternatives it just generated and say, actually, alternative B looks better now that I've thought it through. Let's consider switching.
So it's forced to justify its work, like a human architect would in a review.
Right.
It's subjecting itself to a virtual review board.
Pretty much. And a third powerful one is challenging design assumptions.
Going deeper.
Yeah, looking for hidden constraints or assumptions that weren't explicitly stated but might impact success later.
Like what?
Like, maybe the initial plan implicitly assumed all users would be in the US with low latency. The agent might challenge that. The current architecture assumes a US-only user base. If there's any possibility of expanding to a global audience later, the chosen regional database deployment becomes a hidden constraint. Should we reconsider the deployment architecture now to avoid future bottlenecks?
That's forcing some serious forward thinking. That's way beyond just coding what it's told.
It really is. It turns the AI from just a coding assistant into something more like a true intellectual partner in the design process.
Okay, this all sounds incredibly powerful, but maybe a bit abstract. Let's bring it down to earth. The source material included a detailed case study, right? Building a specific application.
Yes, a non-trivial one called the Daily Digest application.
What did it do?
It had a pretty specific and complex set of requirements. It needed to automatically download the top stories from Hacker News each day.
Okay.
Then use those stories to generate a daily 2-person podcast using text-to-speech voices, like a mini radio show summarizing the news.
Wow. Okay. Ambitious.
And then finally deliver that generated podcast audio file along with a text summary to subscribed users via email.
So full stack, scheduled back-end tasks, external APIs, email delivery, audio generation. Definitely not a simple CRU'd app.
Not at all. A good test case for the methodology.
How did they start? Did they use a template?
Yes, they started as recommended with a basic starter template project structure provided by the user. And the BMad agent, being aware of that structure from the start, ensured all the planning documents, and later the code would conform to that template's layout. Consistency from the beginning.
And it went through the whole web flow we discussed. BA, PM, design, architect, PO checklist.
Exactly, the whole sequence.
Hmm.
And the design architect phase yielded a really specific result, apparently.
Oh, yeah. What was the look and feel?
They didn't settle for default components. The requirement was very specific.
Still.
An 80s retro CRT terminal look.
Seriously, like an old green screen.
Yeah, with a green glowing text font and a specific monochromatic color palette. That whole aesthetic vision was captured in the UX/UI spec document. No generic design drift allowed.
Okay, kind of cool, actually. And then the V0 prompt, the front-end generation.
This was highlighted as a magic moment in the case study. Because the agent had the full context, the PRD detailing the pages needed, list, detail, subscribe, the back-end architecture defining the APIs it would eventually call, and that very specific CRT terminal UX spec.
Yeah.
The prompt it generated for V0 resulted in a one-shot creation of a full working responsive web application.
One shot, really?
One shot. It delivered the 3 required pages, styled with the retro theme, and already set up to interact with the API routes that the back-end architect had defined. Huge time saver for the front end.
Okay, impressive. So Webflow done, front-end shell built by V0. Then they move into the IDE for the back-end build.
Right, and the developer workflow in the IDE settled into this simple, continuous loop.
Using those specific IDE agents.
Yes, sm.ide for the Scrum Master, and dev.ide for the developer agent. These are specifically tuned to look for that BMad docs folder structure and the standard artifact file names like datamodels.md or projectstructure.json.
And the loop is just. Scrum Master prepares a story, Dev agent codes it.
Fundamentally, yes. The Scrum Master agent takes the next charted story from the PRD sequence, adds any necessary detail or context based on previous steps, and hands it off. The dev agent then implements that story, writing the code, tests, etc.
But you mentioned a feedback loop. That seems key.
Absolutely crucial. It's not just fire and forget. As the dev agent works on a story, it populates that story's file, usually a markdown file, with notes, progress updates, completion status, and critically, any problems it encountered.
Like what kind of problems?
Maybe it struggled setting up a specific AWS CDK construct, or it hit a weird linting error it couldn't auto-fix. It documents these issues right there in the completed story file.
Why is that documentation so important?
Because the Scrum Master agent reads those notes from the previously completed story when it prepares the next story in the sequence.
Ah, so it learns from past mistakes.
Exactly. Let's use the CDK example. Say in story 1.5, setting up initial infrastructure, the dev agent documented a struggle with a specific CDK version conflict.
Okay.
When the Scrum Master agent drafts the next story, story 1.6, deploy initial API endpoints, it reviews the notes from 1.5. Seeing the CDK issue, it might proactively adjust the instructions in story 1.6. Maybe it explicitly tells the dev agent to use a different command or pin a specific package version, or includes a manual configuration step to avoid the known problem.
So the AI team learns and adapts in real time, story by story. It stops repeating the same stupid things.
Precisely. The development process naturally gets smoother and more robust over time as the Scrum Master incorporates learnings from the dev agent's feedback.
Clever. Is there anything preventing the agent from just rushing ahead?
Yes, there's a safety check. If the Scrum Master goes to prepare, say, story 1.7, but it sees that the previous story, 1.6, hasn't been marked as done or signed off by the human user,
It stops.
it stops work on 1.7 and prompts the user, saying something like, "Hey, story 1.6 doesn't seem to be complete yet. Please review and mark it done before I proceed with 1.7.
So it enforces sequential development and makes sure dependencies are met. Keeps things orderly.
Exactly. Prevents the agent from building on unstable foundations.
And one final observation from the case study related to the models themselves.
Yeah, just a note that the specific model used in the demo, Claude 4 Sonnet, was apparently miles ahead of previous versions they'd used, like Claude 3.7 models.
In what way?
Specifically in its ability to automatically fix linting errors and failed unit tests. The combination of the very detailed, explicit stories coming from the BMad V3 sharding process, plus the increased capability of the newer LLM.
It just makes the whole development experience much smoother.
Significantly more robust, efficient, and reliable. Especially when you get into the weeds of fixing those annoying little dependency issues or getting tests to pass. The better model handles that grunt work much more effectively when guided by the detailed plan. #outrag_outro.
Okay, so let's try and wrap this up. If we step back and look at the big picture, BMad V3 seems like a really fundamental shift in thinking.
I think it is.
It takes that scattered, often inefficient, sometimes costly vibe coding approach.
which works okay for small stuff but fails at scale.
Right. And it transforms it into this structured, highly customizable, agile team orchestration system. It's about bringing architectural discipline to AI development.
Discipline that allows you to actually leverage the raw speed of these modern LLMs effectively without the chaos.
And it sounds like it's applicable across the board. Greenfield projects starting fresh.
Yep. Brownfield projects where you need to integrate with existing systems.
Or just managing complex dependencies anywhere in between.
And we really should stress the accessibility point again. That was a major focus for V3, fixing the setup complexity of V2.
So getting started is genuinely easier now.
Much easier, based on the description. Clone the repo, install dependencies, copy one core agent prompt, and then just upload those maybe 6 or 7 specialized BMad knowledge files.
Like the master checklist.txt or the data model template.md.
Exactly. Upload those directly into whatever environment you're using, Gemini, custom GPTs, maybe others in the future. It's designed to be portable.
And customizable, right? It's not a locked box.
Absolutely. The whole system is meant to be tweaked and adapted. They expect the community to share suggestions, refine templates, new task definitions, evolve the method collectively.
So, okay, boiling it down for you, the listener, what does this all mean for you? It seems like this method offers a clear, managed pathway from just a seed of an idea.
All the way to a fully implemented, architecturally sound application.
And crucially, it seems to drastically reduce the cognitive load of managing AI development. It handles the complexity.
And by forcing that planning up front, using the AI to help with the plan, it keeps your resource cost, those token credits, much lower and more predictable. Less waste.
Okay, final thought then, a provocative one maybe.
Let's hear it.
We talked about those advanced reflective elicitation features in V3. The agent challenging its own assumptions, generating alternatives, defending its choices.
Yeah, the self-critique aspects.
Does this represent a turning point? Are we seeing AI development tools that are starting to become capable of actual self-correction, of critical architectural thinking and defense, rather than just, blindly following instructions?
That's a fascinating question to end on. It's moving beyond just execution towards analysis. A tool that's beginning to question its own answers. That ability to question, maybe that's the most valuable feature we'll see in the next generation of AI-assisted engineering, something to definitely keep an eye on.